We're going to go back to problem of the day, like we always do at this beginning show. And there it is. And by the way, this is today's problem of the day. Some of you wonder, well, are we going to get yesterday's problem of the day in? We'll get around to it. Those of you hanging out on Facebook, just be patient, all right? But let's take a look at this one. A hemisphere has volume of 18 pi cubic centimeters. That's a half a sphere, by the way, a hemisphere. What is the length of its radius? So we've got 18 pi cubic centimeters. That's because it's volume, got to be in the cubics. And the length of the radius we're going to look for. So let's take a look at this one. There is a great thing called a formula that we're going to go to. And then we'll eventually get to the calculator. But our formula for volume of a sphere, let's start off with it. 4/3 pi r cubed. Because you say, well, Ernie, why are you going with the sphere? Because a hemisphere is going to be what? 1/2 of that. So here we go. We're going to take 1/2 of the sphere. So we're going to go, this is the volume of a sphere. We're going to go for the volume of the hemisphere. And we're going to take 1/2 times 4/3 pi r cubed. All right, so what happens when we take 1/2? Well, guess what? We're going to get a little cancellation action going right there, which looks like our volume of the hemisphere actually is 2/3 pi r cubed. Now, folks, does that make sense to you? Because we basically had 4/3 and we're going to take half of it. So guess what half of 4/3 would be? 2/3. But just to get you a feel for it, it didn't just come out of the sky. Don't just pie in the sky, no pun intended there. It comes in that way. All right, just comes right out of the fact that half of 4/3 is 2/3. Now, we've got a formula. You say, well, Ernie, what are we going to do with it? Well, what are we looking for? We're looking for the length of the radius. And we do know the volume. We know the volume is 18 pi over here. So let's go ahead and set this thing up. 18 pi equaling 2/3 pi r cubed. Now, let's just take this thing piece by piece. You know and I know that I hate to deal with fractions, all right? So we're going to use the value here of 3/2, we're going to run the reciprocal through, and that's going to put us in a way that we can at least lose our fraction there, all right? So what's happening here, we drop a 1 underneath that 18 pi, like we like to do, and we can see some things working out very nicely here. So let's check it out. First of all, we have the 2 going into the 18, I believe 9 times, and we have 3 times 9, which gives us 27. And we have a pi that's hanging on for dear life here. Now, what happened with the 3 and the 2, 3/2 over here, and the 2s and 3rds? Oh my goodness, all of them are canceling. That's why we chose that, all right? So we picked that to get that to work out for us. Now we have an equals, and we got pi r cubed. Getting close. And what's nice, we don't have any fractions right now. Yeah, everybody says that's good, that's good. So let's do the next step. We're going to divide it out, the pi, right through here. And say goodbye to pi, goodbye to pi. You say, well, Ernie, what just happened? Well, remember, we're trying to figure out what r is. Pi is the same value on either side, so it just basically divides itself out. Nice little division property of equality and the power of 1 going on there, all right? When you get those to basically go to 1. So now we're down to a much easier thing to look at. We got 27 equaling r cubed. And some of you are going like, ooh, cubes. Because we think of squared a lot of times, that's when we talk about area, but here we're in cubic units because of, well, guess what? It's 3 dimensions here. So at this point, we're going to take the cube root. And by the way, some of you may not have seen us use this before, but we put a little 3 down in there, and we're going to cube root both sides there. And that's going to give us, well, what is it going to give us? Looks like it's going to be 3. Because what? 3 times 3 times 3 catches, 27. There you go, 9 times 3. So there you have it, 3 to the 3rd. And it looks like r cubed. Well, if we cube root that, we're just going to take it down to r. That's the idea. So there is your radius. I believe that is in centimeters. All right. So we're going to have the radius equaling 3 centimeters. And let's go and see, did it work? My goodness, with all this starting from the beginning, basically if we go back and put in 2/3, and we have our pi, and we have our 3 to the 3rd power, do we get 18 pi. That's the question mark, big question mark. Inquiring minds everywhere wanting to know, is it going to work? Of course it'll work. We hope so. Hit that 3 to the third. We know it's 27. So we got 18 pi here equaling 2/3 pi times 27. I'm catching the 3 and the 27 doing some good things. So it's going to give us a 9. And you know what that's going to be? 18 pi to the left, 18 pi to the right. Checks out. Our final answer works well for us. So a lot of thinking going through this one, I know. First of all, we start with the formula. We get the 2/3 going. And we use some fractions. Now, somebody said, Ernie, could we have gotten the pi out of there to begin with? Absolutely. You could take the pi out right off the bat, and you would have had something that looked like what? You would have had 18 pi equaling 2/3. Well, you would have lost the pi, right? You would have had 18 equaling 2/3 r cubed. And at that point, you can work from there to get rid of the fraction again. It's, once again, I chose to remove the fractions because we don't really like those very much. Get them out of the way first. Then the pi's disappear very nicely. So there you go, problem of the day. And let's get some problems going here.